Hello everybody, welcome back. So I just wanted to quickly discuss vectors and how we draw vectors. We've talked a lot about vectors having direction and magnitude, but we haven't really shown how that's drawn. In Physics 20 and Physics 30, and if you take physics outside of high school or even engineering, you will use a lot of vector diagrams and drawings with vectors in them. So we have to find a way of making it so that people understand what direction the vectors are acting. So what we're going to do is, there's two ways that we're going to look at. One of them is based on the planes. So the horizontal plane obviously being the x-axis, and the vertical plane being the y-axis. These two here, these two examples, show the same thing. They're both acting at the same angle, but they're using different numbers. This one is acting at 20 degrees from the horizontal. So that would be how we explain it. We would say 5 meters per second at 20 degrees from the horizontal. Whereas this one is 5 meters per second at 70 degrees from vertical. Now, these two are fine and they work, but it doesn't really tell us exactly which way, because this could also be 70 degrees from the vertical. So this kind of lacks a little bit, and it really is only good for vectors that are in this section of the coordinate system. So how can we make that more accurate? Well, let's look at an example as if we do still have that okay example. So if we have a wagon here, and it's being pulled with a force of 4 newtons. Remember, force is measured in newtons, at an angle of 50 degrees from the horizontal. So let's assume that it's in this quadrant. So our force comes up with an angle of 50 degrees, so about I'm actually going to move this so that it's more better aligned. There we go. 50 degrees from the horizontal. So that would be how we draw that. The alternate way we could draw that is by putting it here, but instead of doing 50 degrees from the horizontal, we could say 40 degrees from vertical. Both would be accurate, but again, it doesn't identify this problem or even these ones here. So a better way of doing this would be to use a compass system. So if I wanted to do that 50 degrees from the horizontal, we could discuss it based on north and east. So what we're going to call this one is 50 degrees north of east. And what that means is just go to east and then go 50 degrees north of it. So if I use that in blue and I kind of describe that, from east you go 50 degrees north of it. That's what this means. The alternate way with the 40 degrees, I'll make this in red again. And we'll use green. This would be 40 degrees east of north, which means you go north and then you do 40 degrees east of that to get your 40. If I did another example here, I'll do this one. I'm going to draw 30 degrees south of west. So again, I'm going to go west and go 30 degrees south of it. The other way we could describe this one would be 60 degrees, and that would be from south we went west. So that would be 60 degrees west of south. Now, if I said 45 degrees here. What would that be called? Well, I would say 45 degrees. Now if this is west and this is north, we're in the northwest quadrant. This is going to be going 45 degrees north of west, or since it's a 45 degree angle, it's also 45 on the other side. We could also say 45 degrees going west from north. Another example here for you. Over here, if we'd made this 33 degrees, obviously it's not to scale, this would be considered either, and both of these are right, 33 degrees south of east, because remember this is east, and you're going south from that east, 33 degrees, or you could call it 57 degrees, because that's this one, and you're going east from the south coordinate. So let's do an example. Let's try that same wagon. So we have our wagon here, and it's being pulled at an angle of 34 degrees north of east. So you find east, which is here, and it's being pulled 34 degrees north of that. And again, from question 1, it has a force of 4 newtons. Okay, so this is just kind of a FYI for when in the future when you get to vector diagrams and you need to use angles with your vectors.